Hey everyone, and welcome back to the deep dive. We interact with databases constantly, probably without even realizing it most of the time, like checking the weather, ordering something online. It's all powered by databases. They're sort of the invisible engines of our digital world. Today, especially for you, our listeners tuning in from the Dr. Sam Pack College of Business and beyond, we're taking a deep dive into management information systems. We're really going to unpack these foundational powerhouses, databases, and database management systems. Our conversation today is primarily guided by some great insights from Richard Tedmon and Casey Wilhelm's Connect Master,
Yeah.
Management Information Systems. It's a McGraw Hill text from 2024, an excellent resource we'll be drawing from. And hey, before we jump in, if you like what you hear, make sure to hit like, subscribe, follow, share, comment, all that good stuff. It helps us out and keeps you in the loop. So think about it. Every time you check the weather app, stream a movie, scroll through social media, you're touching a database. Seriously, no matter what your future career goals are, whether it's marketing, finance, HR, operations, understanding how these systems work is, well, it's pretty much a certainty you will be using them.
It's really quite remarkable, isn't it? Just how deeply integrated databases are into, well, everything we do, and how absolutely foundational they are for any modern business. It's not just about, storing data like in a big digital box. It's about making that data truly useful, making it accessible, reliable, so you can actually make smart strategic decisions with it.
Okay, so when I hear database, honestly, my mind kind of jumps to just a massive spreadsheet, like Excel on steroids. But then I hear DBMS, Database Management System, and that sounds, I don't know, much more sophisticated, more complex. Am I thinking about this the right way? Or is there a really key distinction I'm missing here?
That's actually a great starting point. You're definitely not alone in thinking that way initially. A database is basically an organized collection of data. Think tables, relationships between those tables. It's the filing cabinet, essentially, full of information. But the DBMS, that's the program. It's a powerful software system, the engine, that lets businesses actively create, process, and administer all that data. Think of it less like the filing cabinet and more like the expert librarian who knows exactly where everything is, how to organize new information coming in, how to ensure security, and crucially, how to retrieve specific details quickly and efficiently.
Right, the librarian analogy helps. Okay, so let's paint a picture. Imagine you're starting a small online business, maybe selling handmade wooden toys, super niche. Initially, you might just track customers, products, sales in simple files, maybe spreadsheets like we mentioned. But as that business grows, what are the real pain points? What happens that makes jumping to a proper DBMS indispensable?
Yeah, and that's exactly where the traditional file systems like spreadsheets start to break down pretty quickly as a business scales. As our source material highlights, you run into some really critical issues, things like data redundancy, data inconsistency, and maybe most importantly, serious data security challenges.
Okay.
A DBMS is specifically designed to overcome these very problems.
Okay, let's make those problems really concrete, maybe give some examples. Like data redundancy. Let's say a customer accidentally gets entered 3 times in your simple file system. You send out an email discount, boom, they get it 3 times. How does that make your company look? Probably not great, right?
Exactly. Disorganized, unprofessional.
And worse, maybe if you're trying to count unique sales for the day, those duplicate entries completely skew your numbers. You get an inflated, inaccurate picture of your actual performance.
Or think about data inconsistency. This one's subtle but damaging. What if you list a red sweater as red in one file, scarlet in another inventory list, and maybe cherry in a sales report? Yeah. So when you try to query for red sweaters to see how they're selling, you'll miss crucial sales data tied to scarlet or cherry. You won't know your true inventory levels. You won't understand sales velocity. And that directly impacts your reordering decisions. You might order too many or too few.
And simple things too, like sales dates being inconsistent. Some recorded by day, others by week. Forget trying to pull an accurate daily sales report for analysis.
Impossible. Your analysis is flawed from the start.
And then the big one, data security. This feels critical, especially today. What are the actual risks if sensitive data gets compromised? Like employee info, customer private details, credit cards, maybe even your secret business plans.
The risks are enormous. For customers, you're looking at identity theft, financial loss, a complete breach of trust. For the business itself, a competitor could gain access to your proprietary designs, your pricing strategies, your customer lists, fundamentally undermining your market position, not to mention the legal and reputational damage.
Okay, so those are some serious problems. How does a DBMS step in?
Exactly. A DBMS tackles these head-on by significantly enhancing what we call data integrity. It's all about ensuring your data is reliable, accurate, consistent, and truly aligns with your organizational goals. You can trust the information you're seeing. And a huge part of how it achieves this is through data centralization. Instead of having data scattered in different files across various departments, maybe on individual computers.
Yeah, the classic silo problem.
Precisely. A DBMS manages your data in one cohesive, controlled system. This makes it inherently more consistent, much easier to secure, and ultimately more trustworthy. It ensures your data isn't just stored, but that it's actually true, meaningful, and useful for making those critical decisions.
Okay, so we get the why DBMS are so crucial, especially as businesses grow. Now let's peel back another layer and look at the how. How do these systems actually organize and manage all that information, particularly in what are called relational databases? It sounds like it starts with some basic building blocks, tables, records, and fields. Is that right? A database is basically a group of tables, and each table has rows and columns.
That's the core structure, yes. Within these tables, we have some crucial concepts that define how the data is organized and how tables relate to each other. Fields are simply the columns in a table. They represent specific characteristics or attributes of the thing the table is describing, like customer name or product price or order date.
Okay, columns are fields. Got it.
And records are the rows. Each row is a collection of fields containing all the information about one specific item or person. So one row in a customer table would have all the details, name, address, email, etc., for a single customer. That whole row is a record.
Fields are columns, records are rows. Simple enough.
Now here's where it gets interesting for connecting information. Keys. There are two incredibly important types. First is the primary key. This is a unique identifier for each record within a table. Think of it like your student ID number. It's unique to you and only you within the university system. No two students have the same ID.
So every row in a table has a unique primary key.
Ideally, yes. That's how the system distinguishes one record from another unambiguously. Then you have the foreign key. This is a field in one table that directly links to the primary key in another table. This is how you create relationships between tables. For example, in your orders table, you'd have a customer ID field. That customer ID would be a foreign key.
That links back to the primary key in the customer's table.
Exactly. That's how you connect a specific order to the specific customer who chased it. You can look up all the customer's details using that link. And these keys working together enforce something called referential integrity. It's a fancy term, but it just means ensuring accuracy and consistency across those related tables. It prevents things like having an order in the system with no matching customer, an orphaned record.
Right. Keeps things tidy and accurate. Makes sense. And you mentioned data definition and data dictionaries. What role do they play?
Think of the data dictionary as, well, the ultimate guide or blueprint for the database itself. It doesn't contain the actual business data, like customer names, but it contains the metadata. That's data that describes the data. So the dictionary defines what each field is called, what type of data it holds, text, number, date, any constraints, like uniqueness for a primary key, maybe even a description of what the field means.
So it's like the instructions for how the database is built and what everything means inside it.
Precisely. It's absolutely essential for database administrators, the DBAs, and developers to manage, understand, and modify the database structure correctly. It ensures everyone's on the same page about what the data represents.
Okay, that clears things up. So you've got this beautifully structured data, organized in tables, linked with keys, all defined in the dictionary. Fantastic. But how do you actually talk to it? How do you ask it questions, get specific information out, or maybe generate custom reports for your business meetings?
That's where SQL comes in.
Yeah.
It stands for Structured Query Language. SQL is essentially the standard language, the lingua franca for interacting and communicating with relational databases. It's how humans tell the database what they want.
So it's like learning a specific language to ask the librarian for exactly the right book or piece of information.
That's a good way to think about it, yeah. And SQL statements are incredibly powerful and versatile. They're not just for asking for data or retrieving it. You can use SQL to update existing data. Maybe a customer changes their address. You can use it to add new data. A new product is launched. You can delete old data, remove discontinued items. And, very importantly, you can use it to generate essential business forms and complex reports by pulling data from multiple tables simultaneously. SQL has specific components, statements, queries, expressions, clauses like where or from. Predicates that allow for very precise commands to manipulate and extract exactly what you need.
Okay, could you give us a couple of really simple examples just to get a feel for it?
Sure. Let's say you wanted to get a list of all the cities and towns where your customers live, just the town names. A simple SQL query might look something like select town from customers.
Okay, select the column town from the table customers. Pretty straightforward.
Exactly. Or say you wanted to find all the information every field for customers who live specifically in Boston. You might type something like select from customers where town Boston.
The asterisk means all columns.
Correct. Select means select everything. And the where clause filters the results, only showing rows where the town field is equal to Boston.
Wow, okay. It seems quite logical once you break it down, almost like constructing a sentence.
It is, and that's part of its power. And the strategic implication here is just vast. SQL is fundamental across pretty much every modern business sector because almost all of them rely heavily on structured data. Think about marketing. Professionals use SQL constantly to query huge customer databases, segmenting audiences with incredible precision to target campaigns effectively. Show me all customers who bought product X but not product Y in the last 6 months. That's in SQL query.
Right. Makes sense.
In finance, analysts use SQL to extract and analyze vast financial data sets, incredibly quickly looking at transactions, market trends, portfolio performance. And in healthcare, it's extensively used to manage and analyze sensitive patient information records, appointments, billing data securely and efficiently, ensuring compliance and supporting clinical decisions. It's everywhere.
That's incredibly powerful for structured data. But
Yeah.
what about data that isn't so neat and tidy? Like you mentioned the fire hose of information from social media feeds or sensor data from thousands of Internet of Things devices, or maybe even just free-form text document. That doesn't really fit into nice rows and columns, does it?
You're absolutely right. The sheer volume, velocity, and variety of data generated today, much of it unstructured or semi-structured, presented a challenge that traditional relational databases weren't really designed for. And that's where NoSQL databases emerged. The no doesn't necessarily mean no SQL at all, but often not only SQL. These are non-relational database systems designed specifically to handle that massive scale, the constantly changing nature, and the diverse formats of modern data. They often prioritize flexibility and speed over the strict structure of relational models.
So they trade some of that rigid structure for agility.
In many cases, yes, they offer rapid scalability, making them excellent for handling huge, continuously changing data sets spread across many servers. Our source identifies 4 main types, each suited for different kinds of data and tasks. You have key-value databases, which are very simple, storing data as pairs of keys and values. Think user session data or preferences, super fast lookups. Then document databases, which store data in flexible documents, often looking like JSON objects. Great for content management systems or product catalogs where each item might have different attributes.
Okay.
There are also column-oriented databases, optimized for reading and writing columns of data rather than rows. They compress well and are fantastic for analytical queries over large data sets. And finally, graph databases, which are specifically designed to store and navigate relationships. They focus on the connections between data points, making them ideal for things like social networks, fraud detection, or recommendation engines.
Interesting how specialized they are.
They often are, yes. And sometimes they're used alongside traditional relational databases to handle specific types of data or workloads.
And you also hear a lot about cloud databases. How do they fit in?
Cloud databases are essentially databases, either SQL or NoSQL, that are built, deployed, and accessed through a cloud platform like AWS, Azure, or Google Cloud. The big advantages are scalability. You can easily ramp resources up or down, accessibility from anywhere via the web, and often managed services where the cloud provider handles things like backups and patching. They offer tremendous flexibility for businesses of all sizes.
Gotcha. So we have all this data, structured and unstructured, stored in various types of databases, maybe in the cloud. What does this all mean for actually turning that raw data into, actionable business insights, making smarter decisions?
That brings us squarely into the realm of big data. And it's more than just a buzzword. Big data really encompasses all the tools, technologies, and processes required for managing these incredibly large and complex data volumes, specifically with the goal of using analytics to uncover patterns, predict future behaviors, and gain a competitive edge.
So it's about making sense of the sheer scale and complexity.
Exactly. It's about extracting value from information that was previously too large, too fast, or too varied to analyze effectively. Big data is often characterized by the 4 V's, which help define its nature and challenges. First is volume. Just the sheer scale, the enormous quantity of data being generated every second. Terabytes, petabytes, exabytes.
Mind-boggling numbers.
Then variety, the different forms data takes. Structured data from databases, yes, but also unstructured text, emails, social media posts, images, videos, sensor readings. Third is veracity. This is about the trustworthiness or quality of the data. With so much data coming from so many sources, ensuring it's accurate, meaningful, and useful is a huge challenge. Garbage in, garbage out, right.
Right. Data quality is crucial.
And finally, velocity. This refers to the speed at which data is generated and the speed at which it needs to be processed and analyzed, often in near real time. Think about analyzing stock market data, detecting credit card fraud, or monitoring social media sentiment during a crisis. The value of the data diminishes incredibly rapidly. If your analysis isn't fast enough, the insight arrives too late to be useful.
That velocity point is critical. Acting on stale data is pointless, or worse.
Precisely. It's about seizing fleeting opportunities or averting immediate crises based on data that's current now.
Okay, this incredible influx of data, the 4 V's, and need to process it effectively, that leads us directly to business intelligence, BI systems, right?
Absolutely. BI systems are the tools and technologies that organizations use to collect, integrate, analyze, and present business information. They pull data from various sources, operational databases, data warehouses, maybe external sources, to provide a comprehensive picture of operations. This includes historical trends, current performance, and even predictive forecasts to help decision makers steer the business more effectively.
So BI is like the dashboard or the command center for the business built on top of all this data.
That's a great way to put it. And within that command center, you have key components. You often start with data warehouses. These are large central repositories designed specifically for analysis and reporting, not for day-to-day transactions. They integrate data from many different operational systems into a consistent format.
So pulling data from sales, marketing, inventory into one place for a bigger picture.
Exactly. And for more focused needs, say, just for the marketing department or the finance team, you might create data marts. These are smaller departmental subsections of the data warehouse, tailored for specific functions, maybe tracking inventory levels or supply chain transactions for the operations team.
Okay, warehouses for the big picture, marts for specific departments.
And to process this mountain of information at the required speed, especially for complex analysis, businesses leverage technologies like in-memory computing, which keeps data in the computer's main RAM instead of slower disk drives, and powerful analytic platforms that combine hardware and software optimized for data analysis. And then there's OLAP, which stands for Online Analytical Processing. This is a crucial capability within BI.
OLAP, what does that let you do?
OLAP enables complex calculations, trend analysis, sophisticated data modeling, forecasting, budgeting, planning, all interactively. Think of your business data not just as a flat spreadsheet, but as a multidimensional cube, a data cube. OLAP tools let you slice, dice, and pivot this cube rapidly.
Slice and dice.
Yeah, like view sales by region, then drill down into sales by product within that region, then maybe slice by time period. It lets you explore the data from countless angles very quickly to uncover insights that might be hidden in simple reports.
Ah, okay. So it's about exploring the data interactively in multiple dimensions. Very cool. And that leads us to data mining and web mining. Are these related to OLAP?
They are related in the sense that they're all about extracting value from data, but they're distinct techniques. Data mining is more about discovering hidden patterns, correlations, and predictive information in large data sets. It uses sophisticated statistical techniques and machine learning algorithms to find things you weren't necessarily looking for, predicting customer churn, identifying fraudulent transactions, finding associations between products people buy together.
Finding the unknown unknowns in the data.
In a way, yes. Creating actionable information from patterns you didn't explicitly query for. And web mining simply applies these data mining principles specifically to data gathered from the websites, social media, e-commerce platforms, server logs.
Okay, so analyzing user behavior on a website, for example.
Exactly. And the insights can be incredibly granular and, frankly, quite powerful. Our source gives a fascinating example. Imagine a user posts a photo online. Maybe their cat eating cantaloupe from a bowl in the kitchen. There's schoolwork visible on the fridge, maybe some dirty dishes on the counter. A sophisticated web mining system analyzing the image and associated text could infer a lot. This person is likely an animal lover, specifically a cat lover, maybe interested in healthy food, cantaloupe for a cat, probably a parent of small children, schoolwork, and perhaps has a somewhat relaxed attitude toward neatness. Dishes.
Wow, that's a lot of detail from one photo.
It is, and this incredibly detailed insight, aggregated across many users, can profoundly influence a business's future decisions, how they target ads, what new products they develop, how they personalize customer engagement. It's about understanding the customer on a much deeper level.
Okay, that's both amazing and maybe a little scary. Which brings up a crucial point. With all this data being collected, stored, analyzed with such powerful tools, what does this all mean for making sure it's managed properly, ethically, and securely?
That is absolutely paramount. And that's where clear database policies and robust administration practices come in. These are the essential guardrails for your entire data ecosystem.
So what do these policies cover?
They set the crucial rules of the road for data. Things like who has permission to access what specific data? For instance, who can see sensitive employee sick time records versus who can only see aggregated sales figures. They also define procedures for how data is collected, how it's maintained, kept accurate and up to date, how it's backed up, how long it's retained, and how it can be distributed or shared, both internally and externally. This entire framework falls under the umbrella of data governance. It's about establishing clear accountability and processes for managing data as a critical organizational asset, ensuring it's handled consistently, securely, and responsibly throughout its entire lifecycle.
And who are the key people involved in making all this happen?
You have several crucial roles within this data ecosystem. The database administrator, DBA, is often central. They are responsible for the day-to-day maintenance, management, security, and ensuring the databases are performing optimally. They handle backups, recovery, tuning.
The keepers of the keys, so to speak.
In many ways, yes. Then you have the database developer, who focuses more on designing and implementing the database systems themselves, creating the schemas, writing stored procedures, optimizing queries for applications. You also need a system administrator who manages the underlying infrastructure, the servers, operating systems, networks, and often implements disaster recovery plans for the whole system, including the databases.
Right, the hardware and OS layer.
And of course, you have the users of the data, increasingly data scientists and analysts, whose job is to extract insight from the data to support informed decision-making across the entire organization. They work closely with DBAs and developers to get the data they need.
That makes sense. It takes a village, really.
Yeah.
What about best practices for the administration side?
Absolutely critical. These are non-negotiables for any organization serious about its data. Things like frequent and tested backups you have to know you can actually restore from them. Continuous monitoring for performance bottlenecks, errors, and potential security breaches. Implementing robust security measures at multiple levels. We can talk more about that. Ongoing performance optimization and tuning as data grows and usage patterns change. And using clear, measurable, maybe smart data quality metrics to ensure your data isn't just there, but it's actually accurate and reliable.
You mentioned security measures. Can we dive a bit deeper into database security specifically?
For sure. Database security typically involves thinking about protection at three crucial layers. First is the database level itself, securing the database software, the internal data structures, the stored procedures, applying patches promptly. Second is the access level. This is all about permissions. Who can read what data? Who can modify, insert, update, delete data? Defining roles and granting privileges carefully. The principle of least privilege is key here, giving users only the access they absolutely need to do their jobs.
Don't give everyone the admin password.
Please don't. And the third layer is the perimeter level. This involves network security, firewalls, intrusion detection systems, protecting the database infrastructure from external threats trying to get in. We also rely heavily on recovery techniques to ensure data integrity, even if something goes wrong. A system crash, a hardware failure, even a mistaken deletion. Techniques like rollback undo allow you to reverse incomplete or erroneous transactions, while commit redo ensures that completed transactions are permanently saved and can be reapplied after a failure. These maintain consistency.
Okay, security and recovery are vital, but you also touched on data quality earlier, and it sounds just as important. The source mentioned a simple error, like accidentally deleting a 0 from an inventory count, changing, say, 3,000 widgets to 300. That seems small, but the consequences.
The consequences can be disastrous. Based on that incorrect 300 number, your company might think, wow, widgets are flying off the shelves. We only have 300 left.
Yeah.
So they might rush to place a huge reorder for thousands more widgets that in reality aren't selling nearly that fast and won't sell. You end up wasting valuable capital, warehouse space, maybe dealing with spoilage if they have a shelf life, all from one tiny data entry error.
That paints a vivid picture. So it's not just about collecting massive amounts of data. It's about constantly ensuring that data is clean and accurate. That sounds like a huge ongoing job for any organization.
It truly is. It's an ongoing commitment, not a one-time fix. Like maintaining a healthy body, you can't just eat well for 1 week and expect lasting results. You need continuous effort. To manage this, organizations use techniques like data quality audits and data scrubbing. An audit typically involves statistical analysis of the data to identify inconsistencies, anomalies, missing values, and other quality issues. It provides a report card and recommends areas for improvement.
So finding the problems.
Right. And data scrubbing, sometimes called data cleansing, is the active process of fixing those problems. It involves finding and then removing or correcting errors like duplicate records, misspellings like our red versus scarlet example, formatting inconsistencies, inaccurate values, or even syntax errors in stored SQL code. A good scrubbing plan identifies the bad data, determines the correct information if possible, removes or replaces the incorrect data, and updates the database, often using automated tools but sometimes requiring manual review.
It sounds like a continuous cycle of auditing and scrubbing is necessary.
For most organizations with significant data assets, yes.
Okay, one last area I want to touch on because it's everywhere now. AI in databases. How is artificial intelligence changing this landscape?
AI is having a significant impact, definitely. One major way is by assisting with the front end, obtaining, extracting, and structuring data, especially from unstructured sources. Think about AI tools that can read and understand text in documents, pull specific information from images, or even accurately transcribe handwriting. This can automate data entry and significantly reduce the human errors we just talked about.
So improving data quality right from the start.
Exactly. And then when AI is coupled with the vast data sets of big data and the analytical power of BI, the synergy is truly transformative. AI algorithms can analyze customer data to provide a much more complete, nuanced view of individual preferences and behaviors, leading to hyper-personalization. It drastically improves forecasting accuracy, helps optimize pricing dynamically, and boosts customer acquisition and retention efforts by predicting needs and tailoring interactions.
And what about security?
Big impact there, too. AI excels at pattern recognition, so it can identify anomalies that might indicate cybersecurity threats or fraudulent activity much faster and more accurately than traditional methods. It helps proactively identify and mitigate potential risks. What's fascinating here is how these technologies, databases, big data, AI, BI, all work together, creating insights and protective measures that were, frankly, unimaginable just a decade or two ago. It's a very dynamic space.
It really is. Well, that about wraps up our deep dive into databases and their absolutely critical role in management information systems today. We've covered a lot of ground from the basics of tables, records, keys, all the way through SQL, NoSQL, the challenges and opportunities of big data, the power of business intelligence, and the vital importance of data governance, security, and quality. We really hope this discussion has given you, especially our listeners at the Dr. Sam Pack College of Business, a clear understanding and maybe sparked your curiosity to learn even more as you prepare for your careers. These concepts are truly foundational.
Absolutely. And to leave you with something to think about, consider a large, complex company you admire, maybe a global tech giant or a major international retailer. Given everything we've discussed today, data policies, security layers, the different personnel involved like DBAs, developers, analysts, what kind of internal conflicts or maybe organizational challenges do you think they might face in ensuring that only the right people have access to specific sensitive data? How do you think they navigate that complex balancing act between making data accessible enough for efficiency and innovation while keeping it secure and compliant? It's a constant tension.
That's a great question to ponder. How do they manage those internal controls and potential conflicts? Definitely something to think about. We hope this deep dive has been valuable for your learning journey. If you found these insights helpful, maybe learned something new, doing a quick like or subscribe really helps us reach more listeners like you. And please share your thoughts on that final question or anything else from today's discussion down in the comments. We genuinely love hearing from you and joining the conversation. Thanks for tuning in.